Sound insulation refers to the use of components to separate the noise from the receiver and cut off the transmission of audible sound, thereby reducing the degree of noise pollution. Sound insulation components include walls, floors, acoustic enclosure, sound insulation, chamber, acoustic barrier, etc. The sound insulation principle and the calculation method of a single sound insulation component have been discussed in Chapter 12. Now let's learn the calculation method of a sound insulation of a composite component. Assuming that a combined sound insulation member consists of n submembers, the product of the transmission coefficient and the area of each submember is its transmission amount. The ratio of the total transmission amount to the total area is the average transmission coefficient. Next, let's do an exercise. It is known that the sound insulation of a wall is 50 decibel and the area is 20 square meter. There is a door on the wall. The sound insulation of the door is 20 decibel and the area is 2 square meter. Find the sound insulation of the combined wall. First, find the respective transmission coefficients according to the respective sound insulation of walls and doors. Then the average transmission coefficient of the combined wall is obtained using the respective areas and transmission coefficients of the wall and the door. Note, after the door is opened on the wall, the area of the door needs to be deducted from the area of the door, which is 20 minus 2, which is equal to 18 square meter. Finally, the average transmission coefficient is substituted into the calculation formula of sound insulation, and the sound insulation of the composite wall is 30 decibel. It can be seen from the calculation results that the sound insulation of the combined wall is nearly half lower than that of a single wall. Think about it. What would happen if the door was opened? What would happen if the door was replaced with a small hole? How to design the thickness of the wall? What measures can be taken if sound insulation is not up to standard? From the calculation method of comprehensive sound insulation, it can be seen that the sound insulation of combined sound insulation components will be greatly reduced due to a weak link. But it is difficult to improve the sound insulation of all subcomponents. The technical and economic constraints are difficult to improve, and improving the sound insulation of other subcomponents will not help. Therefore, the design of combined sound insulation components usually adopts the principle of equal transmission. That is, the transmission of each subcomponent is approximately equal. Since the area of the door is about 1/5 to 10/5 of the area of the wall, the sound insulation of the wall can be 10 decibel higher than that of the door or window. Next, let's do an exercise with first formula. There is a window with a width of 1 meter and a height of 2 meters facing the outside, and there are gaps with an average width of 1 millimeter around it. What is the maximum sound insulation of the window? If the sound insulation of this window is to be increased to 28 decibel, how much should the gap be reduced? Windows and gaps are equivalent to combined sound insulation components. It is known that the gap faced outdoors and the transmission coefficient is 1. The area of the window and the gap can be compared with the size of the window and the width of the gap. Using the equal transmission design principle, the transmission coefficient of the window multiplied by the window area is equal to the transmission coefficient of the gap multiplied by its area, and then the transmission coefficient of the window is obtained. Then, using the sound insulation calculation formula, the sound insulation of the window is 25 decibel. If the sound insulation of the window is increased to 28 decibel, its transmission coefficient should be 10 to the power of minus 2.8. Still following the design principle of equal transmission quality, the area of the window and the transmission coefficient of the gap remain unchanged, so that the area of the gap is 2 times 10 to power of minus 2.8. Since the length of the gap is constant, the adjusted gap width is 0.5 mm. That is, the gap width needs to be reduced by itself. Another exercise using the second formula on the basis of example 1. Given a wall area of 20 square meter, a door is opened on the wall. The sound insulation of the door is 20 decibel, and the area is 2 square meter. What should be the sound insulation of the wall? What is the sound insulation of the composite wall? First, according to the design principle of equal transmission, the area of the wall and the door and the sound insulation of the door are substituted into Formula 2, and the sound insulation of the wall should be 29.5 decibel. Then, according to the sound insulation formula, the transmission coefficients of walls and doors are obtained. Then the average transmission coefficient of the component's wall is obtained according to the formula of the average transmission coefficient. Substituting the average transmission coefficient into the sound insulation formula, the sound insulation of the composite wall is 27 decibel. Let's compare example 1 and example 3. The area of the wall and the door and the sound insulation of the door are the same. The sound insulation of the combat wall is only 3 decibel different, and the sound insulation of the wall is different by 20 decibel. It can be seen that it is economical and reasonable to select wall components according to the design principle of equal transmission. This figure gives the combat wall sound insulation for different types of doors. As can be seen from the figure, sealing and quality are beneficial to improve the sound insulation of the combination door. When the sound insulation of the door reaches a certain value, the sound insulation of combat wall will not increase. The noise reduction value D of the room refers to the sound pressure level difference between the surrounding room and the receiving room, and is a final indicator for judging the actual effect of room noise reduction. It can be seen from the calculation formula that this value is not only related to the sound insulation of the partition wall, but also to the total sound absorption of the receiving room and the area of the partition wall between the two rooms. Therefore, effective measures to reduce room noise are not limited to improving the sound insulation of the partition walls, but also be achieved by increasing the sound absorption of the received room and reducing the area of the partition walls. This formula can be used to select the partition wall structure and can be used to check whether the room meets the allowable noise standard when the sound insulation of the partition wall has been determined. Next, let's do an exercise. It is known that the area of the partition wall between the two rooms is equal to 20 square meter. The sound insulation is equal to 30 decibel. The surface of the receiving room is equal to 120 square meter. The average sound absorption coefficient is 0.2, and the sound pressure level of the surrounding room is 70 decibel. Find the D value and the sound pressure level in the receiving room. The amount of sound absorption is equal to the sound absorption area multiplied by the sound absorption coefficient, and then substitute into the sound insulation volume of the partition wall and the partition wall area, and D is equal to 30.8 decibel. From the definition of D, it can be known that D is equal to the difference between the sound pressure level L1 of the surrounding room and the sound pressure level L2 of the receiving room. So let L2 is equal to L1 minus D, which is equal to 39.2 decibel. It can be seen that the sound insulation of the partition wall has the greatest effect on the noise reduction of the room. Using the law of mass to increase the thickness of the partition wall will occupy the building area and increase the construction cost, which is not desirable. So please think about it. What is the best way to improve the sound insulation of the partition wall? How to design? How to choose materials?